Welcome to lesson 9.3, multiplying binomials and multiplying trinomials by binomials. So in our first step here, we want to multiply the binomial by a binomial. So in order to multiply these, we have to make sure that each term in the first binomial is multiplied by each term in the second binomial. So I am going to multiply the 4x by the 3x and the 4x by the minus 6. So 4x times 3x is 12x squared. And then 4x times minus 6 gives me minus 24x. Now I also need to make sure that I multiply that 2 by the first and second term in the binomial as well. So 2 times 3x is 6x, and then 2 times minus 12, or minus 6 gives me minus 12. So now I have, when I multiply that binomial times a binomial, I'm left with 12x squared. See how our two terms are like. So that gives me minus 18x minus 12. Okay, you may have heard the term FOIL. FOIL is just a kind of a trigger word that we use to remind us to multiply every term in the first binomial by every term in the second binomial. We get that word FOIL by saying, did you multiply the first terms in both binomials? Did you multiply the outer terms in both binomials? Did you multiply the inner terms of both binomials? And the last terms in both binomials. First, outer, inner, last. That's what we call FOIL. And it's just a word we use to remind us that we're multiplying every piece of one binomial by every piece of the second binomial. We're distributing. So here's an example of why we need to multiply polynomials. We want to find the area of the shaded region, and we want to, so we're going to have to find the area of the big rectangle, and then we're going to have to subtract out the area of the small rectangle. So what we're going to do here first is let's find the area of the shaded rectangle, okay? And we'll do that by taking the 3x plus 2 and multiplying it by, that's a bad 2, sorry, the 2x minus 1, okay? And then we want to take away from that, we want to take away the, and I'm going to use double parentheses here, the x times x plus 3, okay? That's what we're trying to find the area of the shaded region by doing that. So the first thing we want to do is multiply our, and get the shaded region, the big box. So it's 3x plus 2 times 2x minus 1. That's going to give us 6x squared minus 3x plus 4x minus 2. And then we're going to subtract x squared plus 3x. Okay, so we want to rearrange, combine like terms, write it in standard form, okay? Write it in standard form, so we have to be careful here. So now what I've done is I have simplified the second line down to 6x squared plus 1x minus 2, and then notice how I distributed that negative, so it's minus x squared minus 3x. I want to combine like terms some more. And the 6x squared minus x squared gives me 5x squared, okay? And then the 1x minus 3x gives me minus 2x, and then minus 2 does not have anything to combine with. So this right here, 5x squared minus 2x minus 2, is the simplified expression representing only the shaded area of that rectangle. So here we're going to multiply a trinomial by a binomial. And we want to make sure that every term in the trinomial is being multiplied by every term in the binomial. So you want to do this in an organized manner so that you don't miss anything. So my first step is going to be, I'm going to take that 3x and x squared and multiply it by the 2x and the 7. So 3x squared times 2x gives me 6x cubed. And then 3x squared times 7 gives me 21x squared. And then I'm going to just take the minus 2x and multiply it by everything in that second binomial again. And that's going to give me minus 4x squared and minus 14x. Notice how I'm kind of lining things up in columns so that it makes seeing and organizing my work and combining like terms a little easier. You don't have to do this, but it just we don't create this big run-on polynomial that we then have to work super hard to organize in our final step. So then my final step is I'm going to multiply the 3 by the 2x and the 7. So 3 times 2x gives me a positive 6x, and then 3 times 7 gives me 21. So now I've got all of my columns lined up, and I can combine like terms, and I'm left with 6x cubed plus 17x squared, and then I've got minus 8x, and then plus 21. Signs are going to be super, super important here. In our final example, we've got another binomial times a trinomial. Notice how this one is kind of multiplying in a little bit different order. We're really doing the same thing. And again, just like 4 times 6 is the same as 6 times 4, if we really wanted to reverse one of these or move one around, we could do that, and it's not going to cause any issues. Okay, so I'm going to follow the same, I'm going to follow and multiply just like I did, just like the problem is set up. So I'm going to take that 6 and multiply the 6n and multiply it by each piece of the trinomial, and then I'm going to take the minus 8. And I'm also going to line up my columns just so, again, I can combine my like terms pretty quickly. So 6n times 2n squared gives me 12n cubed. And then 6n times n gives me 6n squared. And then 6n times 7 gives me 42n. Then I'm going to multiply the negative 8 by the 2n squared, and that gives me minus 16n squared. And then negative 8 times n gives me minus 8n, and then negative 8 times 7 gives me minus 56. I then combined all of my columns, and I'm left with 12n cubed minus 10n squared plus 34n minus 56. As always, please make sure you complete the post-video check and be very specific if I've lost you in any of these steps.